Hi everyone, this is Real World Audio, and today I'm answering a question that is a very valid concern. So Tiago asked whether the transformer in my current volume control solution can it induce noise to the input selector that sits on top of it. So let's have a look at it. So here's my unit. This has the two transformers inside, which are the AVCs. AVC, I wrote it there. And AVC means autoformer volume control. So basically, there are two units like this, approximately this size, sitting inside. And those are the ones that do the volume control change. And here, this thing on top, that's my input selector switch. So that's where the inputs go in. And Tiago asked whether those transformers there prove any problem for the input selectors. So as they do their job of changing the volume, of course, we all know that transformers, when you have current running through them, then they create a magnetic field. So inside here, there are coils like that light colored thing. There are coils inside, and then they produce an electromagnetic field, and the electromagnetic field is focused into these so-called laminations. And the laminations keep the field, instead of just being spreading out, they keep it focused inside the core. And however, if that's the case, the question is, when we operate a transformer, what are the conditions when that electromagnetic field, that magnetism, those magnetic lines, when can they escape from the magnetic core? Because we all know that when you have a transformer, let's see, we have like loads of transformers here, and some are much bigger than these small transformers, and others are true giants compared to this transformer. So what is the condition when a transformer spews forth so many magnetic lines that it creates a big hum that it can be picked up by neighboring circuitry and cause you problem? So here we go. For a transformer, you need to pass through a signal that is getting closer to the rated power of the transformer. And in that case, there are so many magnetic lines produced by the coil that the core is unable to hold on to them, because it's saturating. So when your core is saturating, that's when the magnetic lines start to expand, because there's not enough magnetizable material to keep those magnetic lines inside within the confines of the unit. And in that case, how much of these magnetic lines can spread and how far they can spread? If we are talking about big units, like these two, like this guy here is around 150-200 VA core, so it means volts times amps. So provided power factor is 1, this could handle up to around 200 watts of power. And if we throw more than that, or around that time, if we throw 200 watt, which is at or near core saturation, then we can expect those magnetic lines to be spreading quite far away and causing problems. So if that was the case, that we force 200 VA, then here we would see pickup. But because of the distance between them, this pickup can be minimized. However, if they were, like for example, the transformer was next to the other core, the pickup would be so much stronger yet, because look at that, if the transformer laminations are match, so they run in the same direction. This is when the pickup is efficient. If I rotate it 90 degrees around, there's much lower pickup possible between the units. So if I were to pass close to saturation amount of electricity through this transformer, and I had another transformer here, then this would pick up enough hum and noise to make it audible if they were oriented like that. If I orient them like this and leave a couple inches between them, then there would be still some pickup, but not to the level that we can hear it. It will be enough to mess around with your low level signal, so it will not feel as alive, as natural as before, but you will not be consciously able to pick up any hum or noise. If they are almost touching, then yes. However, we are talking about 100-watt level situation. Now, what is the situation inside the autoformer? So here we have a core that is around the size of 10 VA, so 10 volt amps, which is around 10 watts. So it means that if I'm running a current that is on the order of several watts, then I am risking that scenario when this transformer will start emitting magnetic lines to create problems in its vicinity. However, those transformers are sitting at that level, and there's this much, like 5 centimeters distance to the selector switch. So even if I would be passing 1 watt or more through these transformers, it would not be efficiently coupled to whatever is in here. And in addition to effectively couple whatever this transformer is radiating, there I would need another transformer, because the selector switch doesn't have any coils in them. So it means that whatever magnetism it picks up, it will be very low. So in order to have any problem with this input selector switch, I would need to place it on top of this giant, and I would need like at least 200 or 300 watts run through that power transformer to make noticeable hum through the input. So now how much are we running through the autoformer? And you will be now a little bit surprised when your DAC or output source is nearly clipping out. So we are feeding it, let's say 2 volts input. Because of its high impedance, the total power through this unit is on the order of a millionth of a watt. So we are light years away from radiating any sort of magnetic lines or magnetism into its surroundings. So the autoformers or transformers in your volume control will never ever induce hum in anything near it. Even if you put your big huge coil around it and put sensitive probes, you will not be picking anything. Yet the other situation is valid. So these transformers do not pollute the environment because they pass through so little current, resulting in such little power that their radiation is literally non-existent. And that is when we are talking about near clipping DAC output levels. During normal listening levels, they have the cores are not saturated, the cores are filled with 1 billionth of a watt magnetism, and at really quiet passages 1 trillionth of a watt is the power level that is stored inside these units. So it is below negligible, but that also means that they are beyond sensitive to magnetic lines to other transformers. So what we should be take care of is to protect them from others, so they will not hurt any other device because their power level is so low. But if you have like huge giants sitting next to them, then you have to be careful not to introduce any harm through those big guys, because if anything is going on there, they will pick it up. So what you can do is to place them at a distance. You see, they are at about 30-40 centimeters distance from the big boys, and that's enough so that they do not pick up any noise from them. Also, I have to add that even though they are gigantic and they look like super scary, and you would think that they radiate tremendous magnetic noise around them, but they don't, because that's like many hundreds of VA core, but it's passing through less than 40 watts of power when it's operating. And when you do that, when you operate a transformer under 10% of its rated power, all the magnetic lines are collected, are centered within the unit itself, and it's not radiating any power. So it is beyond, far away from being stressed, and all the magnetic lines are kept inside. The same is true for these transformers inside the AVC. They can keep all the magnetic lines inside, so they are happy. So I hope this answers the question, and we learned something about transformers. Thank you for tuning in. Please like, subscribe, share with others. Bye bye.